Hello, our topic is visualizing retrograde motion of planets. We're going to learn why planets appear to go retrograde, and we will understand when they go retrograde. Okay, well, just to make this clear, I'm sure this is obvious to almost all of you, from the heliocentric perspective, planets do not go retrograde. Planets are moving in the same direction. The planets that are closer to the sun are moving faster, and there's a nice animation of it at umd.edu. This is the exact website address, and there's the animation showing the sun. That little dot in the middle is the sun, yellow dot, and Mercury, the innermost planet, moving fastest. Venus is next, a little bit slower. There's the Earth, which is light blue, a little slower, and Mars is going slow enough you can probably read it. There it is, this red one. And then way out here, here's Jupiter on the right, looking much slower. So obviously the planets all go around in the same direction, and that's what the solar system looks like. They change speed slightly because the path of the planets is elliptical, and in that elliptical orbit, when the planet is a little closer to the sun, or in some cases like Pluto, it could be a lot closer to the sun, it goes faster. So the planets do speed up and slow down heliocentrically, but not as drastically as they do geocentrically. And in fact, geocentrically, the planets can appear to go backwards. But I want to make it clear, they don't go backwards heliocentrically. They're spinning around just fine. Okay, so how is it that from the Earth's point of view, geocentrically, the planets appear to be going backwards? Well, I have an image and also an animation about this. Okay, first, the image. Okay, very simple image, and I'll show you a nice animation. Here we have the sun, this orange circle that represents the sun. This gray circle represents Venus as it travels around the Earth, around the sun. So here's Venus at this point in time traveling around, then it would reach here, and then it would reach here, and come back around. And here's the Earth at a given point in time. So we are on Earth, and when we look at Venus, when Venus is conjunct to the sun, when it's near the sun, it's either in front of the sun or in back of it, right? Maybe you never thought about that before, but when Venus is conjunct the sun, there's two possibilities. Venus is on our side, it's on the Earth side of the sun, or it's way over here on the other side of the sun. And when Venus is over here, close to the sun, there's a term for it to distinguish these two types of conjunctions to the sun. This is called an inferior conjunction, and this is called a superior conjunction. And what happens is that when Venus is in the inferior conjunction, when it's closer to the Earth, it appears to be going backwards. And I'm going to show you an animation that demonstrates this in a moment. But the animation whizzes around real fast, and I want to give you an idea about what's going to happen in the animation first, before we look at it. So when Venus is here, it appears from the Earth's point of view to be going backwards. And when Venus is over here, on the other side of the sun, it appears to be going very fast, because the sun is going this, the Earth is going this way, and the Venus is going that way. They're going in opposite directions, and we don't realize we're moving when we're on Earth. We think we're still, even though we're moving. The sun appears to be moving, even though it's us on Earth that are moving. So we're going this way, Venus is going that way, makes Venus look like it's going very fast. And when Venus is over here, it's retrograde. So when Venus is conjunct the sun, there are only two possibilities. Either it's an inferior conjunction, and Venus is retrograde, which means appears to be going backwards, or it's moving very fast. That's it. Moving very fast at superior conjunction, or it's retrograde at inferior conjunction. Now I'm going to show you the animation, and hopefully with this information you'll be able to follow it. Oh, one more thing. When Venus reaches its maximum distance from the sun, it's about 47 degrees. In this direction, it would also be another 47 degrees in that direction. So Venus never gets very far away from the sun. And what we'll see in this animation that shows where Venus is, where Venus appears to be from the Earth's point of view, Venus will appear to swing like a pendulum around the position of the sun, while the sun moves at a fairly constant speed. Okay, let me show you the animation, and this should make more sense. Okay, so back to the browser. Here's the website. It's a website called mheducation.com. And what this animation is showing you is, in the middle is the sun. The gray dot here is Venus, the blue is Earth, and this reddish one is Mars. So it's showing only 3 planets in the sun, just to keep it simple. So we've got Venus, Earth, Mars. Mars is the reddish one, Earth is the bluish one, Venus is the gray one. And you can make some different selections here, and I've selected, we're looking from the Earth at Venus. And what it's showing around the outside is the geocentric position of the Sun and Earth, and the Sun and Venus. The geocentric position of the Sun and Venus, where they appear to be in the sky from the Earth's point of view. And here's this pendulum movement I was talking about, where the Venus is going very fast, reaches 47 degrees, swings back, retrograde, 47 degrees, goes very fast past the Sun, reaches 47 degrees away from the Sun, swings back, another 47 degrees backwards, and so on. About 47, could be less or more. And it just does it, swings like a pendulum around the Sun, so its overall motion is the same as the Sun, but swinging back and forth, like that. And when it's going fast, it's the superior conjunction. It goes fast, goes past the Sun, then very fast retrograde is the inferior conjunction. And if you look closely, you can actually see this. If you watch this animation carefully, here's the Earth, here's our line of sight. We're looking at Venus, and here's where Venus appears to be against the stars. So there's Venus at superior conjunction. Now it's going to get in between Venus's retrograde. Venus is going to go on the opposite side of the Sun, fast. Venus is going to come back around, retrograde. So on the opposite side of the Sun, fast, one more time, comes back around in between the Earth and Sun, and it's retrograde. So that's this animation shows you exactly how this happens. And with Mercury, it's the same exact thing, same exact idea. With Mercury, the only difference is that Mercury stays within 27 degrees because it's closer to the Sun, but the same exact concept. Also has an inferior and a superior conjunction, and at the superior conjunction, meaning Mercury's on the opposite side of the Sun, Mercury appears to be moving very fast, and at the inferior conjunction, meaning Mercury's on the Earth side of the Sun, it appears to be retrograde. So Mercury and Venus work the same exact way. That is the retrograde motion of Mercury and Venus. So it should be very clear now why they appear to change speeds and even go retrograde. Now, for the planets outside the Earth's orbit, the way planets outside the Earth's orbit also appear to go retrograde, but it looks a little bit different. So very fortunately on this animation we can select Mars. So let's see what happens with planets outside of the Earth's orbit, farther away from the Sun than the Earth. So here we have Venus. Here we have the Earth. The Earth is blue. Here's Mars, that's red. And what you're going to notice is that when the Sun is opposite Mars from the Earth's point of view, Mars will appear to be retrograde. So here's the Earth. Sun is moving faster than Mars, and as the Sun approaches being opposite to Mars, so here's the Earth, now they're opposite, and look, Mars is going retrograde. So if you watch it very carefully, again, here's the line of sight, the visual. Here we are on Earth. This line is us looking at Mars. And as the Sun gets opposite to Mars, as the Earth ends up in the middle, Mars appears to go retrograde. So Mars will appear to be retrograde when it's close to being opposite from the Sun. So geocentrically, we see the Sun on the opposite. Let's look at it one more time. Here's the Sun leaving Mars, and Mars is going to slow down and go retrograde just as Mars and the Sun are opposite each other from the Earth's point of view. So that's it. There's the visualization of retrograde. Let's go back to our PowerPoint presentation and summarize this. There's also something very interesting I want to show you about how far away the planets are from the Sun when they turn retrograde. It's very interesting. But just to review this, to summarize the key points here, Mercury and Venus are retrograde when they're near inferior conjunction. So there are two kinds of conjunctions of Mercury and Venus to the Sun. The inferior, where the planet Mercury Venus is closer to the Earth, and the superior, where it's farther away. And when it's farther away, the superior conjunction is moving very fast. So that's how it works with Mercury and Venus. And I mentioned Venus is always within about 47 degrees of the Sun, and Mercury within about 27 degrees of the Sun, geocentrically, obviously. And for Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, for planets that are farther away from the Sun, they appear to go retrograde when they're near opposition to the Sun. And they don't have to be opposition, they're just closer, they're closer to being opposition than conjunct. They're more than 90 degrees away. And here's the thing I want to show you to make this even clearer, is this. Mars will go retrograde when it's between roughly about 135 to 144 degrees from the Sun. So when we look at this animation, and when we see Mars stop, when it's called a station, when it stations, it stations, it's still going forward, and it stations. At that moment that it stations, it's about 140 degrees from the Sun. That's what happens. And Jupiter will station when it's 120 degrees from the Sun, Saturn when it's 108, and Uranus and Neptune when they're between about 102 and 103 degrees. Very curiously, these happen to be interesting fractions of a circle. Mars is about 3/8 to 2/5 of the circle away from the Sun when it stations. When it stops and turns retrograde, or when it stops to go to, when it's done being retrograde and starts to move forward. In both of those cases, you'll get these angular distances. Jupiter will be 1/3 of a circle. So when Jupiter is trine the Sun, it is stationary. So if you're an astrologer, that's an interesting thing. What I'm telling you is that when Jupiter is trine the Sun, it's stationary. That's very interesting. It's something we don't often realize in astrology. I'll say it again. When Jupiter is trine the Sun, it is close to being stationary, because that's when it stations. And when Saturn makes a 3/10 aspect to the Sun, it's stationary. And it's the only time. And Uranus and Neptune station when they're 2/7. Astrologers call it biseptile from the Sun. And I'll show you some information to confirm that. Here I'm in the Sirius 2.0 software, and here's a listing where I've listed every time that the Sun and Uranus are 2/7 aspect, and when Uranus either turns retrograde, RX means retrograde, or turns direct. And look at this, it's incredibly close. Here we're starting in 2000. Uranus goes retrograde on May 25th. Only a day earlier, it's in this biseptile aspect, 2/7 aspect. On October 26th, Uranus turns direct. A day later, it's 2/7. So it's within a day. Very, very, very close. You can look at all these. They'll be within a few days. Let's take another example. Let's scroll all the way. Ran this for 10 years. Let's just take this one. Uranus turns direct on November 27th, 2008. And the 2/7 aspect on the same exact day. Very interesting. Very, very interesting. And if I right-click and I change the settings, if I go to Customize, and I do the same thing for Neptune, and click OK, just so it doesn't get confusing, it's nice to just look at one planet at a time. even though Neptune is farther away from the sun than Uranus, we're going to see that it's also just within a few days. It'll be within a few days that the biseptile or 2/7 aspect occurs and Neptune stations. So here we see Neptune stationing, turning retrograde on May 11. The biseptile to the sun is the next day. Here there's 2 days apart, where the aspect occurs 2 days before Neptune turns direct. So within a few days, for both Uranus and Neptune, the biseptile aspect occurs when the planet stations. Very, very interesting. And I can show you the same thing with the other planets. I'll show you with Saturn. Let's just go in and customize this and change the planet to Saturn. I've got Sun and Saturn. And for aspects, I'll uncheck the 2/7. I went ahead and customized and made a triseptile aspect. And now I can run this. I'm not triseptile, tridecile they call it. It's a 3/10 of a circle. Now I'll run it for Saturn, and you'll see the same thing. Saturn is 108 degrees, which is a 3/10 aspect. Some people call it a tridecile when it stations. So let's see some examples of it. Very first example, Saturn turns direct on January 12, 2000. The next day is the 3/10 aspect. Then later that year, Saturn turns retrograde on September 12, 1 day after the 3/10. So you can go through all these. You'll see that within a day or two. It lines up very, very precisely. Here it's the same day, May 17th, same day, 1 day apart, 1 day apart, 1 day apart. So Saturn stations. In both cases, whether it's turning retrograde or turning direct, in a 3/10 aspect. Just a curious observation. Here's another visualization of it where I'm showing the timeline format, as it's called in the Sirius software, and you can show planets and signs, and I've selected the Sun, Uranus, and Neptune, and it shows that Neptune, this is 2015, is in Pisces, and it's direct. Green, this little green line means Neptune is direct. It's in a forward motion, turns retrograde in mid-June, and down here I've shown these biseptile aspects, and there it is. I'm just showing the same exact thing I showed you in a listing, but in a more visual format. Here's the Sun-Neptune occurring twice in 2015 on June 14th, right when Neptune turns retrograde. Neptune remains retrograde until about mid-November, and that's when the biseptile, the 2/7 aspect, which is 102 degrees 51 minutes, occurs. And here we see it for Uranus. Uranus is direct, turns retrograde in late July. There's late July with the biseptile. And then Uranus turns direct in late December, and there it is, December 25th. The aspect occurs. Same exact information, but shown visually. The visual gives you the sense of how these transition points are also when the aspects occur. Very, very fascinating. So the outer planets are close to opposition to the Sun, and they turn retrograde and direct at a specific distance from the Sun. And that distance ends up being fairly small fractions, very, very precisely. So fascinating. I think there's more to astrology than the number 12. You know, in astrology you have 12 signs, 12 houses. But here you're seeing curious coincidences where planets station, which are critical points, changing direction, right on consistently on these aspects. If nothing else, one thing to remember is that if you see Jupiter trine the Sun, Jupiter will be stationary. If you use minor aspects like septiles, and you see Sun-Uranus in this 2/7 aspect, sometimes called a biseptile, Uranus will be stationary. Same thing for Neptune. So it's a nice thing to know about. Just a curious coincidences. Okay, that's it, my friend. I tried to give you some idea about why planets appear to go backwards. They don't actually go backwards from the Sun's point of view, but from the Earth's point of view, they appear to change direction. Tried to explain that, and lastly, some curious information about how far away the planet is from the Sun when it turns retrograde and turns direct, which we call the stations. Thank you very much for listening. God bless. Namaste.